Hello. In a previous video, I mentioned about the general architecture styles that we can distinguish. And again, in a previous video, I talked about the column style, or more specifically, the functional enterprise system architecture. In this video, we will see the layered style, and in particular, the four-tier or four-layer enterprise system architecture. This is likely to be a longer video than the previous one, but we will see. Let's start. Now, the four-tier or four-layered enterprise system architecture applies the separation of concerns principle in structuring the enterprise system. And the principles are as follows. Those things that belong together should as much as possible be put together, and things should be mixed as little as possible with other things. Yeah? Okay, it might sound a little bit complicated or too philosophical. Let's see how this principle has been applied in structuring the enterprise information systems. Okay, the structure of the enterprise system from the perspective of a four-tier architecture style looks like this. We have, not surprisingly, four layers, but also a layer that cuts across all others. Let's see more details. The first tier is the data logic. At this layer we see the database for persistent data storage and the logic that implements the basic operations on data, such as retrieving, querying, deleting, or updating the data. Okay? These basic operations are used by the functional logic tier, which is just above the data logic. This layer, layer 2, handles the individual business functions that the enterprise system supports. This also includes related business rules and data validation. Okay, for instance, creating an order, or approving an order, or checking an inventory level of a product. They are all examples of functions which reside at this layer. And you have in fact done such operations during your practice with the SAP systems. And all these functions resemble very much an activity in a business process. Now the next layer is the process logic or business process logic, which contains the logic that implements the business process flow or workflow between the individual functions that an enterprise system supports. It concerns mainly the ordering of the functions. For instance, an order has to be approved first before it's fulfilled, for instance. The uppermost layer is the presentation logic, which simply concerns things that are related to the interaction with the human user of the system. This layer simply displays the data to the user and accepts inputs from the user. And finally, the authorization logic contains information about the users and their roles and what they are authorized to do at each tier or at each layer. For instance, you cannot expect anyone to approve an order. You cannot expect, we should say, only managers are allowed to approve orders, and clerks are allowed to create orders, and so on. The information about who can approve an order, for instance, belongs to this layer. Okay, now this figure shows the data flow that takes place between four tiers. So when the user clicks on a control on tier 4, for instance, to save the order that has been created, the request travels all tiers below and reaches to the data logic and finally to the database. Later, the response travels back to tier 4 to indicate to the user that the request has been fulfilled, and in this case, the order has been saved. Now, when passing through tier 2 functional logic, the data is also checked for validity. For instance, if the order total value is not less than a certain value. Now, please note that in many sources, tier 2 functional logic and tier 3 process logic are considered as a single tier and called the business logic. which makes the three-tier architecture. Okay, let's look into the tiers in more detail. The data logic. It contains two sub-layers, if you like. The database itself, which stores the data about business objects, and the data access logic that implements the basic operations on the business objects. Now, before explaining what these components are, we need to understand what these business objects are. Now, business objects are things that are relevant for our operations. For instance, order, for instance, invoice, for instance, products or patients or users. Such objects and their relationships among themselves are typically conceptually modeled using class diagrams, for instance, or entity relationship diagrams. Let me also give some examples of objects that you would see in the SAP system. So, for instance, sales document and a special type of a sales document called credit memo request, and you see the explanation of the object credit memo request in more details in the SAP system. Now, how does it look like in the architecture diagram? The first data logic. On the bottom, we have the database, where the business objects reside persistently, and on top of it, and I mean we see the business objects, and on top of it is the data access logic, which implements again the basic data operations on the business objects. And basic data operations are in the form of create, read, update, delete, and list an object, or in other words, we call these entire basic operations as CRUDL operations. For instance, create an order, delete an order, list a customer are all basic operations. Okay. The data access logic sublayer obstructs the function logic and the database, so that, for instance, the DB can be, the database type can be changed anytime without an effect on any other tier. The idea, in fact, the idea of the entire tier architecture is that the idea is to decouple the things, to make them independent, so that we can change components if necessary without the need to change the other things. So the entire idea is to come up with something modular and easy to change, because change is inevitable, and we need to structure the systems in such a way that we put minimal effort to change, to make the change effective. Okay, now that was the first layer. The second layer, or second tier, functional logic. The second layer handles individual business functions that an enterprise system supports, which also includes related business rules and data validations again. As you can see, we have the data and the tier layer. Business objects reside in data access logic. When functions are called by the upper layer, they go through the data access logic and in fact transform into CRUDL operations here, basic operations, and reach to the database and the same way back. Functions that we mention here, like create order, approve order, or create customer, very much resemble the basic operations, but this might be much more richer in that sense. And the functions here can be mapped to the transactions in the SAP system. We use, you have been practicing SAP systems for the last few weeks, and then you would see that you would see the transactions, and they basically map to the functions. So here is how, in fact, they traverse from the function logic to the data logic. The process logic, tier 3. It contains the logic that implements the business process flow between the individual functions, tasks that an enterprise system supports. So we had data logic 1, the database, data access logic, and functional logic. So simply we have the workflow logic at the process tier or tier 3. Examples include, for instance, order processing, product manufacturing, purchasing processes, and so on. Essentially, in your sub-assignments, you go through such processes and perform several tasks or steps in a specific order. So you follow this process in your assignments. Finally, the uppermost layer contains the logic that implements the interaction with the human user of the system. It displays the data to the user and accepts input from the users. And this layer is also referred to as a front-end layer or user interface layer or graphical user interface. They're all kind of names, other names that we typically use to represent this presentation logic layer tier. Authorization cuts across all these layers. It contains the people, mainly the role and the user information, and what each of these entities are authorized to do at each tier. Here. Access rights are typically provided to roles. And I mean, for instance, at the functional layer, it's assigned to per function. For example, the clerk role cannot update the details of orders above 100K. And note that the authorization cannot be tiered, as it is required at all tiers. So you can define access rights on the data, function, process, and even at the presentation layer. Principles and benefits of tiered architecture. The major principle is that each layer should be unaware of the inner workings of the other layers. So as a result, the application in a tier can be changed or upgraded independently. That's the entire idea behind it. So this increases the ease that the system can be maintained and can be changed. For instance, when you so we can add an additional UI type, user interface type in the presentation logic without changing any other type. For instance, you can implement a mobile interface, iOS or an Android, in addition to the PC browser web-based interface, which uses the same layers underneath. I mean, it will use the same process, function, and data logic layers. Similarly, we'll have a macOS presentation logic layer and another one for Windows environment. And this is the case, for instance, for the SAP that you're being using. This principle has another positive consequence or influence as well. This allows tiers to reside in different machines, different servers or desktops, and this in turn has additional benefits of scalability and reliability. So in this way, you can distribute application components across multiple servers and implement multiple levels of redundancy. For instance, you can separate and deploy data logic in a separate database server and replicate the service in such a way that if one fails, the other would simply take over and continue. For instance, consider banks where the transactions continue for 24/7 and system shutdowns or failures cannot be avoided. So the tiers, particularly the persistent data logic tier 1, is replicated in multiple locations, even in different cities or even in different continents, in fact. Principles continued. Now, every layer can exist without the layer above it, and every layer requires the layer below it to function. Okay. Let me put it in another way. Each tier provides services to tier directly above it, and each tier only uses the tier directly below it. Okay. We need to see some examples so that this becomes a little bit clear. For instance, you did a change in the business object invoice. Okay, suppose now you have a new type of invoice and you need to store the type of invoice, that info, also in the database. And by the way, this is a costly change because this is likely to influence all the tires above it, including the authorization. It's likely to influence all the tires. So because as the information about as the structure of the business object invoice changes, it may influence the functional logic. You may need to rewrite it, considering the new information. The process logic might change, the presentation logic might change. You might need to put another control on the user interface to save this data, and so on. And the authorization might change as well. Might change. Another example. So suppose that you need to change the billing process in such a way that, for instance, you need to add another step or a function in the process. Which tires? So the change is in the process logic, fine. But which tires can be influenced? Now, this change must not affect the invoice object, but it might affect the presentation logic and the authorization. The function does not change, it stays the same, but the presentation logic might change, and the authorization might change, based on the principles that have been defined here. Okay, that was the 4-tier architecture. Again, the idea is not to make you an enterprise system architect, but rather make you informed about these technical concepts so that you can participate in the decision making during the design, implementation, and management of such systems, and also speak the same language with the technology professionals. We'll continue with the series of video, but for now, ciao.